All right, page 847. Let's see. What's the date today? The 8th. Circles in the coordinate plane. And theorem 12, 7-1, equation of a circle, says that the equation of a circle with center HK meaning the h is the x value at the center and k is the y value at the center, and radius r is the letter x minus h squared plus y minus k squared is equal to r squared. So the first part of your assignment today, you'll be asked to write an equation of a circle. And then we'll say with center for -2 and radius equal to 3. So when you're writing the equation of a circle with the center at 4, -2 and the radius equal to 3, here's what it's going to look like. Your equation will be x, and then the formula says x minus h. Minus also means the opposite of. So in this case, the x value of the center is 4. So in here goes a -4. And it's squared. And then it's plus, left parenthesis, the letter y. And then the formula says again, y minus k, or y and the opposite of k. And in this case, the y value at the center is -2, so a +2 goes in here. And it's squared. And it's equal to the radius squared. So in this case, the radius is 3, so out here goes a 9. And that's the equation of a circle with a center at 4, -2 and a radius of 3. So now write an equation with the center at 0, -3 and a radius of 8. Anybody get that? Any questions about that? Why is the x just by itself x squared? You're not going to write x minus 0, are you? I mean, you can, but it'll look funny. All right, x squared is the same as x minus 0 squared. Because x minus 0 would be equal to x. Good. Good. All right, so look at example 1b. They're asking you to write an equation again, but they are giving you, let's see, write an equation of circle B that passes through. Negative 2, 6. And has a center and has center negative 6 and has center B negative 6, 3. Alright, so in this example, what are you missing?
The radius.
You're missing the radius, aren't you? So you need to find out how far it is from the center to the edge of the circle, right? So you can use the distance formula, or you can use the Pythagorean theorem. So if you were to, how many of you are familiar with the distance formula? All right. Distance formula is, let me give it to you in case you want to use it. Distance between 2 points is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So if you're given the center and you're given a point and you need the radius, you can take your coordinates and plug them into the distance formula. So in this case, the distance from the center to the edge of the circle is going to be equal to the square root of, I'm going to label these first. Here's x1 and here's y1, and then here's x2 and y2. So it may help to keep them organized. So let's see. X sub 2, you got negative 6 minus x sub 1 is negative 2 squared plus y sub 2 is 3 minus y sub 1 is 6. And that's also squared.
Wouldn't it be plus 2?
It's gonna be when you keep change and change, right? Good. So what's negative 6 plus 2? Negative 4 squared. 16. 3 minus 6 squared. 9. So you end up with the square root of 16 plus 9, which is 25. And the square root of 25 equals 5. So now you've got your radius, which is the 5, and you've got your center, which is right here, center B. So your formula, or your equation for this circle, is going to be x, and then what?
Opposite of
X plus 6, right?
plus 6. Yeah, it's opposite.
Remember the center goes here, x plus 6 squared plus the letter y and the opposite of your y value, minus 3, squared equals 5 squared, which is 25. So in the first example, they gave you the center, they gave you the radius, you just had to fill in the blanks, right? Second example, they gave you the center, but then they gave you a point on the circle, so you had to find the radius. Okay? So now, once you find the radius, you've got the center, and you've got the radius, and then you're just filling in the blanks again. The h, the k, and the r, right? Okay? So they kind of progress that way through the whole book. Easy example, a little harder example, even a little harder example, then even a little harder example. Right? Very good, very good. Look at example 2a on the next page, graphing a circle. Graphing a circle. This looks like fun. Graph x squared plus y squared equals 25. So now you have the equation of the circle. From that equation, can't you pull out the center and the radius? What's the center? What's the x coordinate of the center of the circle? The x coordinate at the center. What's in the parentheses with the x? There's a 0 in there, right? We just said earlier that x minus 0, you don't write it, right? So the x value here is going to be 0. What's the y value at the center?
0.
Good. What's the radius equal to?
5.
Very good, 5. So could you start to graph that?
Yes.
Could you put it on the coordinate plane?
Yes,
Yes,
sir.
sir. So let's put it on the coordinate plane. The center's at 0, 0. There's your center. Where's it going to hit the y-axis up top here? At 5, right? So 5. Where's it going to hit the y-axis down here at the bottom? Negative 5, because the radius is 5. Where's it going to hit the x-axis out here? On the right. 5. And where's it going to hit the y-axis out here on the left? Negative 5. Okay? So you got 4 points to start with, don't you? These are the points that are a little bit tougher to find, aren't they? So can you do a table of values? Remember doing that? Where you could insert your x values and then you could just evaluate and find some y values. So now, if you, let's say that you use, how about some x and y's? Who could tell me what they would use for an x? What could you use for an x value to insert into this equation?
3.
Would you use 7? Why not? It's not going to be on the circle, is it? It's too far out there to the right. Okay, so 4, because the book used 4. Or maybe something between 0 and 5, right? Do you see how everything in this picture is symmetrical? Isn't everything in here going to be a reflection too? I mean, if you plug in 4 for x, won't whatever you plot here be the same over here? Yeah, so what's 4 squared?
60.
Okay, so if you plug this 4 in, you're gonna get. I'm running out of room. Hopefully, I don't lose you.
If you just do 9, I mean 3.
If you do a 4, you got 4 squared plus y squared equals, what is it, 25? So you're going to subtract 4 squared from each side. So you're going to subtract 16. And what's y squared going to be equal to? 25 minus
3.
16 is 9.
9.
And if you radical each side, then y equals 3. So when you insert a 4, you get a 3. So isn't 4, 3 going to be a point on this circle? So it's about right here, isn't it? So, do you see what else is going to happen here?
So then it would be opposite.
Yeah, I mean, when you put in the negative 4, right? What's y going to be equal to?
-3.
It's going to be a positive 3 and a negative 3, won't it? Because it's going to be symmetrical. Everything's going to be the same distance from the center, right? Do y'all see that?
Yeah.
And you know what happened is down here, if what's the real square root of 9? Y'all remember the plus or minus part that you did in Algebra 1, where if something's squared, if y squared equals 25, you square root both sides, y is equal to positive or negative 5. Because positive 5 squared is 25, and negative 5 squared is also 25. So really, technically right here, isn't this positive or negative 3? So when you insert the 4, you get a positive 3 and a negative 3, right? So you get your negative 3. And when you would do the same thing for the negative 4, wouldn't you get a positive and negative 3 as well? So you would get that point. All right, and then if you had to, you could do it for, you know, positive 1 and negative 1. And then you're just going to do the math and plot the points. But this is probably enough to sketch this thing, right? Just do some little, yeah. Just a really fat circle. Do you get the idea?
Yeah.
I mean, you could at least plot the center and then 4 points, right? Could everybody do that?
Yeah.
Okay. And then if you could just find, if you could pick 2 other x values, that's going to give you 4 other points, isn't it? And then you can sketch the circle. Anybody got any questions?
No.
Okay, so your assignment for today, page 850.
So are we turning in the work now?
I don't know. Do it on a separate sheet of paper in case I feel like collecting it. How's that?
That sounds good.
Thanks. I appreciate it. On page 850, do 1 through 8. And then 10 through 13. On a separate sheet of paper so you don't lose your notes if I collect them.